Alright guys, welcome to this page of the notes, and we're just going to continue with this idea of factoring rational expressions and then finding where it is undefined, giving the restricted domain value. So here we go. Let's jump into this one. What we've got is I take a look at the top and I recognize it's already been factored for me. So that's great. I don't have to do any work in the numerator. But in the denominator, I recognize that I have a general trinomial, right? I have a y squared, which tells me that it's quadratic. But the 6 is not a perfect square, so it's just going to be factoring a general trinomial. So let's go ahead and see what this is going to look like. Again, like we said, I can't do anything in the numerator. It's already been factored for me, so it's just going to be 4y, y minus 3, and a y plus 4. But in the bottom, the y, right, I already have that y. Now I got to factor this guy. What we're hoping is that I'll just simply factor into two binomials. Now I may have to do more work than that, but we're going to start with the simplest case and go from there. Again, I need two numbers that multiply to a y squared, which is the easy bit. That's just going to be a y and a y. Slightly trickier bit, I need two numbers that multiply to a negative 6, sum to a negative 1. Let me think about it for a second, and you should recognize that a minus 3 and a plus 2 should do it for you. So minus 3 plus 2. Again, a minus 3 and a plus 2 gets me a negative 6, and a minus 3 plus a positive 2 gets me a negative 1, which is exactly what I needed. Well, I take a look at it and I go, okay, here we go. The y minus 3 and the y minus 3 cancel each other out, and so what I wind up with in simplest form, or reduced, is going to be 4y times y plus 4 all over y times y plus 2. But I need to find the restricted values, and I do that by setting the denominator equal to 0. So y times y plus 2, set it equal to 0. Well, zero product property lets me split those guys up. So I get y equals 0, I get y plus 2 equals 0, which means y equals negative 2. And so what I know is that I can pick any value of y that I want, pick any number at all, except y equals 0 and y equals negative 2, because both of those choices will give you 0 in the denominator. So we'll just simply put then where y cannot equal negative 2 or 0. And that is going to be your simplified rational expression and telling me what my domain restrictions are. Let's go and do another one. All right, exact same thing here. We just need to first take a look at factoring if there is any. 2z, I can't do anything with that. X plus 5, that's already been factored. I can't do anything with that. But then I take a look and I have yet another general trinomial. I know it's a general trinomial because it's a z squared. That makes it quadratic. 8 is not a perfect square, so I'm hoping it'll factor as a general trinomial. We may have to do more work than that, but we'll start with the easiest case. And then just a quick glance in the bottom, that is already completely factored for me. Z minus 1, z plus 5, and a z minus 2. I can't do anything to any of those. So a little bit of work here in the numerator. 2z, z plus 5, and then let's see if we can get that top to factor. Okay, well, I know to get a z squared, the easy bit, I need a z and a z. Z times z gets me z squared. But now I need two numbers that multiply. Negative 8, sum to a positive 2. I believe a minus 4 and a plus 2 will do it. Minus 4 and a plus 2 will do it. Yep, absolutely. Okay, so then in the bottom, let's see what we've got here. Did I do that right? Oh, sorry. Scratch that. Flip it other way around. I apologize. I need it to be a negative 8, but it needs to be a positive 2. That means that I need a plus 4 and a minus 2. Sorry about that. So it's got to be a plus 4 and a minus 2. Plus 4 minus 2 gets me the negative 8, but plus 4 plus a negative 2 gets me the positive 2. And so that all works out. All right, in the bottom then, I have my z minus 1, I have my z plus 5, and I have my z minus 2. Z minus 2s, z plus 5s, those will all become 1s. And so what I'm left with is 2z z plus 4, and in the bottom, a z minus 1. But now I need to find my restrictions. I find my restrictions by setting z minus 1, my denominator, equal to 0. This one's easy. Z cannot be a positive 1. And I have my simplified form of there's nothing else that I can factor, and I've told you the restriction on the domain value. You can pick any value of z that you want, just can't pick a positive 1. Head on over to the next page of the notes. We'll try a few more of these. I'll meet you guys there.